When you see problems like this, we're going to use the slider in the middle, and we're going to pick the one that represents it. Notice on the left, we have our three variables. P is it's Diane's birthday. Q is we're having pasta for dinner. And R is there will not be any leftovers. So if we take a look at letter A, it says if it is Diane's birthday. So it is Diane's birthday is P. It's an if-then statement, so we represent that as an arrow. Then we're having pasta for dinner. Pasta for dinner is our Q. Oops, I wanted to highlight that. I erased too much. We're having pasta for dinner, so that's our Q. Now, below that, now we're going to look at our statement. Our next statement, might be hard to read, but we're having pasta for dinner. So pasta for dinner, again, that's going to be Q. Therefore, it's Diane's birthday. So we're going to say Q, therefore we use the three little dots to be therefore, P. That's what you're going to represent. That's the symbolic form. That's the second column. We'll talk about it being valid in a second. Let's take a look at letter B. I'm going to switch colors here for letter B so you can see the difference. So on letter B, it's Diane's birthday. We're starting the same way again, aren't we? So Diane's birthday is P. Then we're having pasta for dinner. Well, that seems kind of familiar, doesn't it? We're having pasta for dinner. So that is Q. It's the second line that's different this time. We're not having pasta for dinner. Okay? So we're going to say not, we're going to put the tilde in front of that like we did from the seminar. So we're going to say, oh, that's going to be not Q. Implies, or therefore, it is not Diane's birthday. So that's going to be not P. Therefore, not P. That's how you just slide over until you find the ones that match that. Now, let's talk about what makes something valid. There's three things that make something valid. There's the law of detachment that we did in the seminar. And the law of detachment says that if P happens in Q, then Q, if P happens, Q must happen. If you have a different one, the law of contrapositive, that says if P, then Q. If Q doesn't happen, therefore P doesn't happen. Now what's confusing is that's the only thing that's true about these two. Did your first one, did it match that? It says if Q happens to happen, the conclusion, the only thing we know is the conclusion is true. We know nothing about the hypothesis. So this first one should be not valid. That is not a valid conclusion. Now in the second one, that follows our law of contrapositive, doesn't it? If P happens and Q happens, if Q doesn't happen, therefore, then P doesn't happen. Did I put that in wrong? Yeah, I forgot my tilde on that one. Sorry about that. If you were saying what the heck happened to that, you were right. You were supposed to be not P. So that one is valid. So you're going to be looking at, is it the law of detachment, is it the law of contrapositive, or is it neither? If it's neither, it's not valid. If it's a law of detachment, it's valid. If it's a law of contrapositive, it's valid. And it's a law of syllogism, but usually we don't have too many questions on that. But you might be the first. We'll find out.